Welcome, ladies and gentlemen. My name is Matt Hall, and I'm the Director of Marketing and Missions at the Australian International School in Singapore. Thank you very much for joining me from both Singapore, the Asia Pacific region, Australia, and New Zealand. Today is our second episode in our webinar series called Into the Classroom, where we delve into some of the classrooms from some of our most experienced and dedicated staff from across our three sub-schools. Today, I'd like to introduce to you our very talented Mr. James Midgley. James is first and foremost a senior science teacher in our secondary school. He's globally known through his exciting YouTube channel, where he's fondly known as Mr. M for Chem. He's also an industrial chemist with many years working in industries such as Dettol and Nurofen. He's also our head of Year 12 and much loved by our Year 12 cohort, and a very proud father of young Sakura, who I believe is in Year 1 in our elementary school. So without further ado, James, welcome along.
Thanks for having me, Matt. Good afternoon. Welcome all to the webinar, and thanks for joining.
I've just given a bit of a brief introduction to your very many talents. I did allude to your career as an industrial chemist before you were lucky enough to get into teaching and to come to AIS. Can you tell us about that, please?
Certainly. I did my degree in chemistry with drug design, clearly intending to go into the pharmaceutical industry, which I did. And I started at the bottom, and I used to analyze raw materials of incoming stuff for things from like aspirin to orange flavorings for Lemsip, Dettol, Gaviscon, Disprin, household brands, which I'm sure everyone's familiar with. I quickly leapt up the ladder due to hard work and tenacity, which I still show to this day, I hope, and was made a laboratory manager in charge of many varied analytical techniques, exposed me to many sophisticated pieces of kit, which I've probably not even come across at university, to be honest, but I'm a quick learner. I got my head around that. Then straight after that, I was made a production manager in charge of shift operation of engineers and scientists and production line operatives and warehouse people, all coming together to make Lemsip at the time. I then transferred to a place called Boots Manufacturing in Nottingham, spent 3 or 4 reasonably happy years there managing the production of the household brand Nurofen, which is clearly an ibuprofen tablet. And that's everything from the tableting of Nurofen through to the printing of every tablet, the sugar coating of every tablet, because Nurofen tastes awful without that sugar coating, and then popping it into packets for the global market. So at the time, we were Europe's biggest packing hall, manufacturing. We used to kick out 1 million packets of Nurofen per 8-hour shift. And if we didn't, there were questions to be answered. So straight after that, I saw the light, thought I would try my hand at something different. The beauty of having a chemistry degree is its flexibility and its applicability to many different workplace scenarios. I was maybe thinking of doing a law conversion, which you can do with your chemistry degree in 1 year. And of course, teaching was also on the menu. I thought I'll try my hand at teaching, see how I did. And I haven't looked back, really. I started off in the UK, state school. I was then in Japan as a DP chemistry teacher for 4 years. I was then head of chemistry at the Uplands International School in Penang. I then moved to the island of Guernsey, an idyllic little isle. They're 24 square miles big. I seem to have this thing about islands. On the island of Guernsey, where I was head of chemistry and also the IBDP coordinator. And then I applied to AIS 4 years ago. In 2016, and I was lucky enough to be appointed as head of Year 12 and lead chemistry teacher, which I now share with the beautiful and wonderful Mr. Gardner as well. So that's my history in a nutshell, Matt. Is that what you're after?
That's fantastic. I find it really interesting that you've come from being an industrial chemist and into the classroom, the huge gift that gives our children. Now, before I move on to other slides, I just want to, it's a fantastic photo of you in our very starting slide. And I've got you standing in front of a piece of equipment here. Can you tell me a little bit about it? Because it's into the classroom and it's nothing like for you, it's into the laboratory. And this is one of our senior labs. So can you tell me a little bit about what you're doing and what that is?
Yeah, sure, no worries. So this is a year 11 practical. They're actually practicing their internal assessments, which is 20% of their IB, which I guess we'll talk about in a little while. But the experiment itself, the student is looking at the effect of varying the carbon chain length of an alcohol on the energy content of that fuel. So you can see there are some spirits lamps underneath. The student's been very efficient, and that's 3 pots. It could be ethanol or methanol. My eyesight's not quite good enough to see that from here, Matt. They've got 3 digital thermometers going into a data logger. So the data logger will plot a graph of temperature over time. The student can extrapolate that graph back, do a quick calculation for any chemist listening, that Q equals MC delta T divided by the moles, and you get the energy content of the different fuels. So clearly, the student has a hypothesis to have an idea whether a shorter chain length will give more energy or a longer chain length of the carbon chain will give more energy. And then the student is trialing and testing that within the framework of the internal assessment for their IB diploma. So that's automatic data logging using computing, which is quite a sophisticated way to actually gather data, rather than perhaps not that long ago, we'd stick a thermometer into a beaker and go, oh, that's the temperature. Let's do it again in 1 minute. We don't need to do that. We can use it. The power of computing, Matt, knows no bounds. Yes.
That's fantastic, James. Now, you've mentioned a couple of things there that I'll jump on, but before I go forward, just for our audience, if as you're watching, you come up with some questions, please hold those questions, and at the end, we'll have a conversation where we can put them to James and we will answer them. So what's the beauty of this webinar is it's interactive. So hopefully I'll answer some of them that you might be wondering along the way as I unpack because you can hear beautifully that James has got an extraordinary science background. He's also a very talented teacher, but sometimes we talk in a lingo that other people don't understand. So I'll deliberately slow him down and make him say a few things again. Now, beautifully there you said this is year 11 IB. Can you talk through what is IB and talk through the course that we have at the Australian school? Because we do what the DP is, but you'll explain both those in a second. I'll give you a chance.
Okay, cool. No worries. Thanks, Matt. So this is, I'm teaching the IB diploma chemistry part of the IB diploma. There are 6 areas for the IB diploma which students can choose from. It's supposed to be the keyword is holistic view of the child. They do everything from a long extended essay. They do creativity, activity, and service. So they need to show some contribution to humanity, at least their local community. And then they could choose any mix of subjects which suits them. So it should really be kind of authentic, tailor-made education to the students. So in chemistry, I could have students that are doing chemistry classically with biology and mathematics, or physics and mathematics. That would be the old school mix for an IB, but that tends to happen less nowadays. We tend to get kids doing theatre with chemistry, or history with chemistry, or psychology, or English, or maths, and they can tailor it to suit what their strongest suit is, because at the end of 2 years, they want to maximize their point score to springboard them to the next phase of their academic career, most likely at university on the global stage.
We've chatted before, James, and why do you think, what's the beauty of the IB and the diploma program going forward for students moving past school, like going on to university?
I think in terms of the preparation, I think the only other alternatives, and I've taught A-level as well, just to name drop a little bit, is that they are purely academic. And yes, they are valued. And yes, universities still like them and still wants them. Yeah. But how much more powerful is it for a student to be sat in front of the Dean of Admissions of Oxford or MIT and say, well, I chose to do an extended essay in the effect of UV light on oxygen concentrations of water, because I'm concerned about the depletion of fish stocks in the local river, okay? Or how much energy can I get from a biodiesel, which I made from the takeaway fish and chip shop or kebab shop next door to me. I can take into school, I can synthesize biodiesel, I can do the experiments we were talking about just a few minutes ago and work out the energy content of that, because I'm concerned about fossil fuels and the impact on the environment. So in terms of what's next for students, the IB gives them something that they've personally chosen to investigate with a real good academic rigor to what they're actually doing, so they can sit in front of these interview panels at university and talk about their personal choice, talk about what they found out, talk about the obstacles they had to jump over, talk about it failed. I mean, it's chemistry, it fails. This is it's real life. But how did they deal with that failure? I often say I don't actually teach chemistry, I teach failure and how to deal with it, because so many times kids get it wrong. But that's great because it keeps me in a job, and it means that they are actually much more resilient as learners when they go to university, when all the support mechanism, which I think we do very well at AIS with the wellbeing coordinators and the counsellors and the heads of year and everything else, that pretty much comes away. And as we all know, at university, you are truly becoming an independent learner. It's up to you when you go to the library. It's up to you if you attend your lectures. And the IB, I think, is the most significant stepping stone, or the most meaningful stepping stone that we can give a kid at 16 to get them to 18, and then they can springboard into education. And every year the IB do a study, and the IB kids always come out as the best prepared and ready. That extended essay links straight into a dissertation. That CAS links straight into the social clubs. And universities care about a holistic view of the kid. They want them to be happy. They want them to be productive. Yes, they want to be academically successful. That's one thing in many things. You know, the world cares about well-being now, and I think that's just a fantastic positive thing the IB's been doing since it started in 1964, 1965, whenever it was.
I really agree with you on all of those aspects too. Jumping back to you, I've got this amazing picture of you with that nice piece of kit behind you that you were talking about. And I think what's lovely about AIS is we have some of these nice pieces of science equipment. I'm going to put another slide up here. Can you talk us through this interesting little piece of kit that we've got here?
Now, the reason that we have this piece of kit is this. I've been at the school 2 years. And the first year, I didn't really ask for a great deal. I thought, I'm a new boy in town. I shouldn't ask for too much from my new employer.
Yeah.
And then the second year, I thought, you know what I will do? I'll find one of the most expensive pieces of kit I can find in the catalogue, and let's see what happens. The worst that's going to happen is they're going to say no. This is my tenacity, I suppose, in action. So I asked for this mini GC. GC might not mean a great deal to many people. Excuse me. It is a gas chromatography apparatus. And the last time I saw this was analysing the incipients and excipients, or the active ingredients and the fillers, in LEMSIP, which we used to use as a release of the product specification to the marketplace. So we'd calibrated the GC apparatus at Reckitt Benckiser, as it was in Hull, and the GC knows when to expect the lemon to come off, when to expect the sodium carbonate to come off, when to expect the phenylephrine, when to expect the paracetamol. They come out at specific points, and you can calibrate the GC to quantify for the amount of those products in the product matrix. Now, if you imagine, if you've got a ton of LEMSIP, 1 ton of LEMSIP, each sachet holds, I think it's about 1 gram. Okay, yeah. So 1 gram. So there's 1 million sachets of LEMSIP in 1 ton. If my mental maths is going, I think that's correct. And each one has to be identical.
Yeah.
Okay. How do you prove that each sachet has precisely what it says on that packet? Because medicines we take on trust. We can't buy a jar of chicken korma and taste it and go, oh, that's wrong, that's Vindaloo. We can do that. If we take an aspirin tablet, we can't say that's paracetamol, not aspirin, and I'm allergic to paracetamol, not aspirin, that sort of thing. So it's all on trust. So everything has to be validated. So to have this piece of kit at school is a phenomenal win for us. And we've used it for the last 2 years in the internal assessment I was talking about a little while ago. And every student that's used it so far, touch wood, has received top score for their internal assessment using it. Because the level of sophistication you can achieve with this is way, way beyond what probably you or I did, Matt, when we were at school using a burette, a pipette filler. Or I'm old enough to actually pipette by mouth and suck the liquids up into the pipette. This is the this is very, very powerful, sophisticated piece of kit, which we're lucky enough to have here. Any chemist listening, we can do the Gibbs free energy of esterification reactions. We can work out the Kc value of esterification reactions. And I'm going to stop there before Matt pulls a funny face at me and says, stop talking about so much chemistry.
What I think is wonderful there, though, James, and I know that you bring this to your classes, at year 11, 12, it is significantly academic, high level thinking. And like you just said, you're wanting to get the very top marks. But what you bring to that is by having someone who's an industrial chemist, who's been there in the industry, you bring it into your classroom, you then are able to teach at that very exceptionally high level, which is what a school needs, especially at years 11 and 12, to get our students who are capable of getting the very top grades. And I'd probably be a bit careful with saying this, but I'd say that chemistry is one of the most difficult subjects in the DP. So in a very academic course, one of the most difficult subjects, it's imperative that you have teachers who have got that higher order thinking. So it's wonderful that you go off on those little tangents. I don't mind at all, because everyone will appreciate that it's where you come from. Now, James, I introduced you as world famous before I started, and part of my background for that is you are known on the YouTube as Mr. M for Chem, which is a beautiful sales, nice little tagline that you have. I've got one of your videos here that I'd like to play. Yes, you've even got it on your cup. You and I will just be reminded to put our microphones on to mute, and I'll play a small snippet, and then we'll stop and start, and I'll show the audience what we mean. So here we go.
There's very little that's out there to actually help us, and certainly I was in that position when it started a few years ago. So if I can do a little bit to help others, then I'll consider this a good use of everybody's time. Okay, so let's kick off. Right then, the IA, which was shared in the Chemistry Teachers Facebook group, was this one, which is the to what extent does the size of the central atom in HXH affect molecular geometry by using ligand close packing model framework. Now, first of all, the first things to do when looking at an internal assessment is basically not to do anything. It's to just read the internal assessment. So begin, start to have a read through, keep an open mind. We are guided as moderators to reward where we see positive things, good things, and not to penalise for an absence of things. Now, to clarify that, just because they've missed something, we're not going to penalise it, but if they include something which is incorrect, we may well penalise it, and you will see that as we develop looking at this internal assessment. So the students started off in the standard manner.
So James, I've just paused there. It's wonderful little clip here. So this is a YouTube clip that's out there for everyone to be able to see, for students to be able to see. Now, I'm going to unpack what's some really nice things that you've got on there. First of all, what started you on this journey of deciding to make these clips in the first place?
This is one of my favorite little stories, Matt. Thank you for bringing this up. So our parents are a wonderful parents group, and they have high expectations, as all parents should. I have the same for my kids. It turned out last year, some kind soul in the mathematics department at AIS was making work solution videos for past paper questions. So this parents, quite rightly, said, Mr. Midgley, why are you not doing this? Clearly you want to be. So yeah. I did, and I made some videos, and it was in comparison to now not successful, but at the time I was quite pleased with a few hundred views. Maybe it got to about 1,000 views after 6 months. Now I was quite over the moon that people had actually watched it beyond the shores of Singapore, beyond the shores of AIS. I thought it was great. Then clearly the pandemic happened. Schools went into lockdown, shutdown, circuit breaker, etc., whichever your adjective is you want to use for that one. And the IB came out and said, well, students therefore should do a database or a simulation-based internal assessment. And I did feel sorry for certainly many of our kids and kids beyond the scope of our school, in that there was very little guidance out there about how to effectively do that, how to make that happen. Because if you're doing a simulation, the simulation is just a computer algorithm which is built to give the same results every time. That doesn't give any variation. That is not a real life situation. So how do you hit the criteria when it's not a real life situation?
Yep.
The same with databases. There are very few databases. The ones that we know are credible and are academically rigorous enough, there's probably only half a dozen, but people didn't know them. So I made one video on how to be successful in your internal assessment. And that one turned out to be pretty successful. I had 1,000 views in 6 months, and I think I had 10,000 views in 8 months because of that one video. So I quickly realized that internal assessment was a seam as yet unexplored on YouTube by chemistry channels. So I now have a total of 12 videos. It is now I'm very proud to say, the most viewed internal assessment for chemistry channel on YouTube. And even my most recent video, which I launched at 2 o'clock this afternoon, already has over 100 views. So certainly my name is now known from chemistry teachers, because I look after or work with Facebook chemistry teachers page. Clearly, I share my videos into there. They like them. They give me feedback. I work with them. As you just thankfully showed, I do live streams, so people can ask me questions as I go through marking an IA, or I can share an IA in the Facebook group, ask teachers to mark it, and then I go through it live with them online to get them up to speed, because the change of COVID was just so fast and so swift and caught everybody off guard. And it's no reflection on the IB. There wasn't enough guidance out there, but there was clearly a big hole that needed to be filled. And I was there with the videos, and they've been so appreciated. And I've had some lovely emails, which I'm very proud about, Matt, from all over the world, from teachers saying how useful it's been, because it was just so quick. Yeah.
And I think if I was to jump, the whole purpose is for the learner, James, which is what's absolutely outstanding. And the reason, as we all know from when we're learning, is that the beauty is that students can pause it. They can listen again to what you've said. They can go to the parts that they find relevant. They are there 24 hours a day. So when it suits them, for when they're restudying, they can replay it. And as humans, we're designed to learn things through seeing and hearing, which is the difference between having a blank textbook, right? So you've captured a lot of things. Also, in this clip, you mentioned that you're a moderator. Can you explain to the audience what an IB moderator is and why? Well, after you've finished, I'll tell them why it's so important for us to have you as our school.
Yeah, no worries. I was probably, I mentioned teachers in a difficult situation now, are not quite sure what the path ahead should be in terms of marking their internal assessment. I empathize with that, because 5 years ago, I was in exactly the same position. And I went on a couple of training courses, got myself upskilled, and I volunteered to moderate for the IB. So what that means is that all the schools in the world have to submit internal assessments to the IB information system. And the marking of all the teachers in the world is moderated or is checked by other chemistry teachers who are called moderators throughout the world. So I might be given, the last session I had 165 different internal assessments from all over the world. And I don't look at the teacher's mark. I go through the internal assessment. I award the marks which I believe are accurate for that level of achievement. I then can see the marks from the teacher, and I check whether that teacher is in line with the principal examiner. Now, it might not be immediately obvious. I'm not the principal examiner, clearly. Yeah. But what happens is 1 in every 10 of the internal assessments I see on screen is a seed, and they are totally random throughout my marking. So 1 in every 10 is a seed, and it's checked against the principal. The principal examiner has marked it, and I have to be within tolerance of that principal examiner. If I'm 0, if I'm absolutely spot on, happy days, I can continue moderating for more samples. Plus or minus 1, okay. Plus or minus 2, I might get an email saying you're being too generous or you're not being generous enough on a certain criteria. Plus or minus 3, get out, no more moderation for you this session, you've failed. It's as clear cut as that.
And I think, James, you've explained that very clearly, which is wonderful about one of your many skills. For us as a school, and for any school, what's really important is to have staff that have been moderators and have had their marking moderated, because It means that you can get our students to the very top mark. You understand how to get a perfect score. You understand exactly what the markers are looking for. And it's an absolute crucial part that we look for all of our senior staff. But I think you beautifully mentioned it in this video, which I thought was nice and worthwhile. Listen, I've got another video. So you've got a whole series of these, and I really say to our audience to go and have a look. You've got all of James's YouTube. What was today's one that you published, James? I haven't seen it yet, but what was today's one about?
No problem. I downloaded the examiner's report. So the senior examiner puts out a report each year. This is for the May 20 session. So last year, clearly November's too recent. It made allusions to the COVID situation, to databases. It made allusions to updates about what is now acceptable given that a school may have been closed or the kids have not had access to laboratories, or the major one was that the schools closed down March, and therefore the kids' first draft was what was submitted, not the second draft with the teachers' inputs, so the corrections were not done. So I made a video about the examiner's report and what the May 21 kids can be using in their IA to make sure that they hit that magic 24 out of 24, which all kids should be aiming for. So clearly that's we're onto a winner with that one, Matt. It's looking good. Yes.
I'm imagine it's already clocking up many views. Before I go on, we've talked about IB. What else do you teach though at our school? What else have you taught in the past?
I teach IGCSE to year 9 currently. I have taught to year 10 the previous 3 years. And I also teach year 7 science, and we are currently doing the Great Barrier Reef.
I've taught that exact unit, so it's quite an exciting one, that one, which is not very Australian, but that's quite lovely. I think for the audience purposes, can you talk through our curriculum in the secondary school going up through? Because you articulate this very clearly too, which I've listened to you before.
Absolutely. Well, the IB clearly is holistic and it's got many aspects to it. But at the end of the day, we do want to see a score, and universities want to see the score. So kids have to in some way get used to sitting an exam, preparing for an exam, revising for an exam, and doing the hard yards to actually get the results that they want. So we do the IGCSE at AIS, which I think is a fantastic preparation for the rigors of what comes next. Clearly, I can tell that a student, although the IB says you need no prior learning, they may say that, but it makes such a massive difference when a kid has done some organic chemistry or has done some moles or some electrolysis. And when they start it in the IB, they're not starting from square one. We're starting from a place where they feel like they can actually contribute to the discussion from square one. So we do IGCSE, we do combined science. They're able to do physics, chemistry, and biology clearly to a pretty high level, which I think is fantastic preparation as they embark on their IB studies.
I think what's really important there, absolutely, James, and that is we made a very specific direction when we chose to go with the IGCSE for exactly like you said, and there's some rigor around students studying towards an end exam and having to work towards that as well. Just for the audience out there, curriculums around the world come in bands. So you have a first year of a curriculum. What I mean by that is we have year 9 and 10 make up the IGCSE course. So it's in a band of 2 years. In the first year, we generally introduce new concepts. In the second year, we practice and master. So that makes sense. So 9 and 10 is our IGCSE. When we move into our senior school, we have 11 and 12, which makes up the IB, because again, it's banded into 2 years. The first year, you're introducing new ideas, concepts generally. The second year, practicing, mastering, and doing assessment and moving towards a final exam that contributes a significant portion. So that's why AIS decided to go down that route, and that's why we've got those in our curriculum.
Well, we also, sorry, Matt, we also offer HSC and VET programs, and the IGCSE prepares them equally well for either of those routes going forward. Sorry to interrupt. Yeah.
No, you're absolutely right. There is definitely 2 pathways in our year 11, 12, and they suit different students, which is why it's so important. Well, it's actually 3 pathways because we have the VET as well, which is our hospitality pathway, and which suits certain students as well. So you're quite right. I'd like to, and I'm just going to change here, so the audience might need to work with me. I'm going to play another video here, which is a beautiful piece of you in your laboratory just the other day, not that long ago. I'm pretty sure from memory it's your year 11 chemistry class. I'll just put in our microphones on mute again.
Okay, and here we have Marcio, who is investigating the Belousov-Slobodski reaction, which is an oscillating reaction. One of those fascinating reactions in chemistry that doesn't just start with reactants and ends in products. It oscillates backwards and forwards. So you will hopefully see that the colour has changed to kind of like a salmony pink, and that is becoming less clear or less deep as time goes on. Marcio, can you tell us a little bit about your internal assessment, please?
Yeah, so it's essentially just doing the reaction at different temperatures and seeing the rate of oscillation and how that changes.
Oh, brilliant. And we can see that oscillating beautifully on the bench. So what sort of method are you going to use to calculate the rate of the reaction, please?
I time 5 oscillations and then divide it by 5 because it's the rate of 1 oscillation.
Brilliant. Well done. Excellent stuff. Thanks for your time, Marcio. Good luck.
So, James, if you can tell us, you've given a nice intro to what's going on. This is your year 11 class. Talk me through your laboratory and what you guys are up to.
In this class at the moment, there are 10 students. I think there were 9 this day, so say 9 students. And each one is doing an individual investigation of their own choosing, with a bit of guidance from the teacher, of course, within the laboratory. So at the back, we've got Christian, who is looking at the effect of the dielectric constant, or the different dipole moment of the solvent, on its ability to extract limonene from orange peel. So the reason he did that was to make the laboratory smell beautiful and citrusy and full of orange flavor, which was great. Yeah. Clearly, Marcio is doing the BZ reaction, which I said is fascinating. It just doesn't go reactants to products. It goes backwards and forwards. That's brilliant. Behind Marcio, there is Chloe. I think that's Chloe. Yep. And she's doing the iodine clock reaction. So you can alter the concentration, time the rate, do the reciprocal of the time, 1 over the time, plot a graph, and get a beautiful graph from that one. On the other side of the laboratory, out of sight, is Kaylee, and she's doing the Winkler method, which is looking at dissolved oxygen in water. So I alluded earlier to dissolved oxygen because of fish stocks and the availability of oxygen in the water. She was doing precisely that. So at what temperature is the optimum amount of oxygen be able to be carried by the water? So they're all doing something completely different. It was of all of their own choosing. So I hope, as you can see, they're a fantastic class. They're probably one of the most promising bunch of chemists I've had the fortune to teach for a very, very, very long time, if ever. And they're so involved, they're so engaged, and they really, really want to succeed. And it's a privilege to work with such kids.
There's so many things you've touched on then. I reiterate absolutely, with the students are very focused, and they are an absolute blessing to teach. What is very nice is this is inside your laboratory. This is a custom-built chemistry lab. Can you tell us the difference that I might find in your lab compared to perhaps another lab in the school?
So this is senior chemistry. We have a fume cupboard in the corner, which I'm currently looking at. So if we are producing noxious gases, nitrogen oxides, or anything else that's going to harm people, environment, or place, we can do it in the fume hood. We do have a very wide selection of probes. So we can, you've seen the temperature, we have pH, we have conductivity, we have calorimetry, we have a dissolved oxygen probe, we have the gas chromatograph, plug that one again. We have certain voltmeter. We have, for things that I've probably forgotten about, we've got a whole tray of data logging equipment that we can monitor a reaction by. We have the old classical stuff. We have our burettes and our pipettes and our pipette fillers and our measuring cylinders and all those things. But it is spaced out. Each island has its own sink and supply. We can set up distillation. We have vacuum filtration at the back, so we can do a Buchner filtration and filter under vacuum, that sort of thing. So it's a pretty good halfway house to what you would find in a university chemistry laboratory.
Wonderful. And I think one of the other areas is that I think it even has proper chemistry, chemical washdown capabilities.
Oh, sorry, I forgot about the shower mats. Yes, there is a shower behind the whiteboard in the case of emergencies. We do have a very high-powered shower and eye wash behind there. Sorry, I forgot about that one. Yes.
Yeah, no, it's all the things that you see every day that someone else would probably wonder what in the heck those were in your lab, and why it's so good to have laboratories that are set up specifically to be able to teach us high level. Now, we're just talking safety there, though. We've got some students in front of us. They're wearing an awful lot of safety gear. Can you talk through what is new, or why they're wearing what they're wearing?
Well, Marcio at the front, we can see he's wearing his gloves. He's using, I think it was a cerium salt, which is potentially toxic by absorption. So clearly the student is wearing latex gloves, one layer, and a lab coat, and he's also wearing his face mask to comply with phase 2 regulations currently in Singapore. If the camera had panned right, you can blame my cinematographic skills for not panning right, you would have found Kaylee, who had 2 pairs of gloves on, which were taped to the lab coat, and a face visor, because she was dispensing concentrated sulfuric acid in the fume cupboard into her volumetric flask for the determination of oxygen using the Winkler method. Yes.
It's a nice mix. Now, you touched on there, we are in COVID-2 lockdown. We are in COVID situation in Singapore.
Yep.
We are wearing the face masks. How did you find, we've had lots of commentary, and I think people in Australia and New Zealand and countries that haven't taken the same approach, but how have you found the teenagers' ability to adapt to having to wear masks or follow these procedures?
I would say that the post-16 age group in chemistry are wonderful and are very compliant, and I've never had one problem with students in a diploma chemistry class. Yeah. Perhaps as the younger teenagers and the younger years, they do require some regular reminders about the wearing of face masks and the covering of the nose. Typically, their faces are a bit smaller than the face mask, perhaps, and it does drop down below the nose. So we can understand, but they need reminding more than the bigger students, the taller students, to wear the equipment appropriately. I think is the honest answer on that, Matt. Yeah.
I found it very interesting. A lot of people have said that students wouldn't comply, but they have just got on with it. And we would both have masks on typically, but we are in our own office spaces, or you are by yourself. And it's after work hours in Singapore. It's after 5 o'clock, so it wouldn't make for great webinar. That's exactly right. I think I have our wonderful school one here as well. Actually,
AIS branded face.
And it is.
Yes.
We will look back on that fondly one day. Maybe not fondly, but we will look back with memories.
We shall. Very compliant. No problem with the big kids. Yeah.
Now, also, James, we've talked about your great ability with your industry background, your chemistry teaching, but you're also the much loved head of year 12. Can you tell us about your role? It's the most significant, it's our pinnacle of our school year, of all of our school, in fact. So can you talk to us, the audience, a little bit about your role and what you love in
Absolutely. That? Yeah, I mean, I've been head of year 12 for 4 years now. I'm responsible for the pastoral, or I think the best way to put it is the academic care of the year 12 kids in the last year of their formal high schooling. Many issues I'm sure listeners or viewers will be able to predict, which we deal with on a fairly frequent basis. But I think, they day in, day out prove to me that the perceptions of teenagers that people beyond 30, which I include myself in, are entirely wrong. Okay. So I can walk down the corridor and they're having beautiful little chats at the locker. They're helping each other. The music that they listen to, we perhaps perceive that they're going to listen to the music of now, but they're still playing David Bowie. They're still playing Queen, Diana Ross. They're playing all the hits. That's fantastic. When you ask them to do something, like we were in lockdown COVID and we did the Getty Museum Challenge, where they all had to dress up as different pieces of art and be Mona Lisa or, a Banksy piece of art, whatever it happens to be. And just the level of detail and the application they put into that. And it just raised everyone's spirits. So, they are young adults. They are on the cusp of going to, that wonderful world of university. It's a Gaussian distribution, like anything. Some kids are already over it by the time they start. Yeah. Some kids at the end of it are still not ready to leave, and we coach them along and support them in the best way that they can. Yeah. I think we've got a very vibrant program in year 12 in terms of supporting morale with like sort of muck-up day and the end of year celebrations, but also throughout the year, every week we would have something. It could be a Valentine's treasure hunt, it could be the Getty Museum Challenge, it could, as we began the year, we planned out a beautiful series of speakers and parents that were going to come in and share their knowledge with the kids. And of course that had to stop, but we are flexible, we are resilient, and we changed tack like everybody had to. I'm not claiming any special power to have done that. Everybody did it. That's what we do. And we cracked on with it. And they just responded just so beautifully all the way through it. As I said at the beginning, yes, it's not been 100% rainbows and unicorns, but that's not life. That, reality is different to that. And people will make up and break up. People will fall out. There will be a party at the weekend where the issues need resolving on a Monday morning pretty swiftly before it volcano erupts. So all that is all parts of the fun of the fair, of the lovely and wonderful year 12, as I call them, at Australia International School, Singapore.
Absolutely, James. I think one of the privileges which unfortunately they haven't been able to have is they have the luxury of being able to come down in year 12 to use the parent cafe. And I find it just amazing being able to listen to their conversations. They are by far the best advertisement of any school because they are the end product of all those years of schooling. And like you just said, I think perhaps people's ideas about what teenagers will be like, ours are absolutely beautiful, which goes a long way to explaining why I've been working here for 10 years. I think that they're an absolute delight. The conversation.
Sorry to add a little anecdote here. We did a survey of the kids and their well-beings. We do a couple of times a year. And one of my questions was, to what extent do you use social media? And perhaps others, middle-aged people, I quite happily put my hand up to that one, would perceive them to be all the time on their Snapchat and Facebook and TikTok and whatever it is. And a number of them said, I don't actually do social media. And they were actually affronted that I would ask the question. And implicit in the question was the assumption that all teenagers use social media, and they don't. Some of them have just taken the path of saying, I do not do that, I choose not to do that. And how wonderful it is to have kids say that.
I think that's a great point that you bring up there, James, but it's not by accident. I know the secondary pastoral programs from year 6 all the way up to year 12 are talking about social media, unpacking the risks, having open conversations about what they're putting themselves out to. And the students are then making their own choices, and like I said, maybe we're a bit lucky at AIS, but they're making informed decisions that perhaps aren't what other people assume about year 12s or teenagers as a whole. We have unbelievably talked for now almost 45 minutes, James, and it's an absolute pleasure. But I would like to open the floor to our audience. I know a lot of guests have made special time to come here. Please, if you type into the chat box, so if you just go to the right of the screen, go into your chat box, please type any question that we will put up there, and we will ask James and he can respond as you do. So please feel free to do that. Now, beautifully here, James, we've got your lovely, this is our thank you slide, of course, but on there we've got your very nice branded Mr. M for Kim. I'll just wait for questions to come in, so I'll keep going if that's all right for the next 5 minutes in case we don't hear from anyone or
absolutely
feel that we've answered a lot of the questions. But we did the home-based learning. Oh, actually, we do have one. Let's have a look here. We've got one from Cassandra, sorry. Thanks for sharing, James. How will my child's progress be tracked to ensure they're keeping up with classes? That's a good question.
Okay, Cassandra, thanks so much for your question. Much appreciated. We do have hopefully a robust support system, particularly in year 12. Every student is given a mentor, and that mentor can be someone not particularly involved with the teaching of that student. It could be someone from marketing or from admissions or from wherever it happens to be, as long as they're happy to support one of the Year 12 kids. And that's a check-in for them. So there's the mentor system. We also track academic progress, which I'm guessing you're also alluding to. We have a data dashboard where every student is benchmarked against ALICE testing, which is quite normal in international schools. And every time they do an assessment, we are checking against where their progress ought to be. And if they're behind that, then we put interventions in to hopefully support that student going forward. Our key message is support. We don't do a big stick approach sort of thing. It is about coaching and support all the way through Year 12. So yeah, data dashboard, mentor system, emotional support, and the well-being team will ensure, we hope, that kids are tracking effectively throughout their time at Year 12. We also have 2 key reporting points with messages going home, and our parents are wonderful and very good at emailing in if they have any concerns, and hopefully we are equally wonderful at responding to any concerns that we're sent from parents. We do have a very open door policy at AIS, and certainly I speak with parents every day of the week as head of Year 12 from any issue, ranging from the emotional through to the academic. Okay, hopefully that answers your question, Cassandra.
Yeah.
Okay, Sarah, a great discussion. I'm keen to know what university pathways exist for my child if they study science at AIS. Is it only for Australian universities, or are there more opportunities? Our kids go all over the world, Sarah, all over the world. They go to the Oxfords and Cambridges, they go to the Stanfords, the MITs in America, they go to Japan, they go to Korea, they go to China, they go to Australia and New Zealand. But going back to Matt's earlier points, the beauty of the IB is that is international currency. And that will get you into any university on the global stage, from the very best to the absolute best.
I think that's a great question. And I think what's really important also for our audience to understand is that one advantage of going to a Southern Hemisphere school is that when our students are applying to a Northern Hemisphere university, they're actually doing it with their end grade results. So what they actually achieved, which puts them in a much stronger position because other people apply with what they predictive grades. So because they've already got their exams, they are applying with the exam results, which the universities like. It also gives the students a 6-month gap between the end of schooling and actually starting at that Northern Hemisphere university, which, if you ask any student, is a wonderful gap. It saves them. We often have a gap year, but this can be a gap 6 months. And it can be a chance to move to a place, to do some travel, to look around before they move on to that next part. And the students need that gap, I feel, because it's pretty intense. If you just go straight away from Year 12 and then start literally a couple of months later, like you would if you were in that year, it's nice for them because they've earned that gap. Well, our students certainly have, because they've worked very hard from Year 9 all the way to Year 12 through exam years. So it's a nice little gap. We've got a good question here. What is the HSC?
I think it's what about the HSC, which is, I'm guessing there's 2 possible meanings. I'm assuming you mean matriculation to universities. Clearly, the HSC is Australian qualification, and Australian universities love it, but it matriculates equally to any university on the global stage. And certainly UCAS and the American systems will have they do have conversion charts where you can convert the HSC to matriculate to any university of your choice. So HSC or IB doesn't really matter. It doesn't preclude you from going to any university on the global stage. Yeah,
absolutely. And that's very important for people to understand. It's a different pathway, and let me explain why that suits certain students. Is like James said, in the IB, the students are forced to spread themselves. Well, not forced, but they've got a range that they need to decide, from languages to the arts, to the sciences. They have to choose a higher and a lower. So they're spread. The HSC allows a student to specialize a little bit more. And what I mean by that is they might decide to do more maths and sciences, and they might decide that they're not so good with perhaps the visual arts or the creative side. So it can allow a student a bit of a choice, and we find that really valuable. absolutely go on to all of the top universities and are accepted. We know that from the Australian students in Australia that travel all around the globe. So it's understood and it's widely accepted. And what's so beautiful is that those students all encourage each other at our school. So they also get a lot of those skills when it comes to university interview time. So our careers, people understand how to prepare them best regardless of their course that they've done. So that was a really good question. I was just thinking, someone else went back to, another great point when you were talking, Cassandra asked you about the assessment and how we guide them. I know that in we've developed a fantastic system where we actually go to our students 4 times a year and check their well-being. And we do these check-in surveys for our students. We know it's really important not to assume how children are feeling and how they are. And we thought this was really pertinent in COVID when the students weren't with us, but we were in lockdown. So they were back at their houses and they were dealing with doing some their final years of schooling, a lot of stress, a lot of worry. So 4 times, once a term, we go out to our students and we do a survey that they fill in and it monitors how they are. The wonderful thing about a survey is the students can do it in their own privacy. So perhaps when you ask someone how you are, they just answer, "Oh, I'm fine." But when you've got a chance to do a survey in private, they might actually put down that they're not feeling so good or that they are a bit worried. And as James is, he's head of the Year 12 Pastoral, our pastoral team will look at these results and we can quickly flag students that we need to have a chat to and we need to help them. And what's so beautiful is that we can do that. We can get them the right assistance. We've got a wonderful culture here of being okay to ask for help. We have the Are You OK Day where we're saying where the students have a culture of being open about accepting help and about getting help. So I think that was a beautiful one.
Yeah, and that's absolutely right about the survey that we do. You know, you know some kids are struggling, but what the survey gave us was a number of kids that we were not even aware of, which were wearing that plastic smile in the corridor, were actually underneath that struggling, and that gave us the opportunity to actually help the kids, which I think is pretty unique and special to us as AIS.
And it really is. I've worked around the world, and I think as things have progressed in our understanding of adolescence and behaviour and the effects of anxiety and all those sort of things that students naturally will face, it was world breaking, this system, and I thought it's really worth celebrating and sharing.
Absolutely.
Let me have a look here. We've got. Oh, here's a good question from Sarah. Thank you for answering my pathway question. What are your enrolment periods? Now, I think Sarah, what you're asking about that is for students, we're coming into we are a Southern Hemisphere school year. So for people looking at us currently, January is the beginning of our school year. So it makes great sense to start a school year with the beginning of a classroom. However, our school does have rolling enrollment. So we don't just lock out for one time. You can join us anytime. Obviously, it makes sense perhaps to have it at a nice beginning, like I'm saying, at the beginning of a school term. So for your children to start term 1, term 2, term 3. Clearly, when it comes to our upper senior school, we couldn't have someone joining us in year 12 because like I said, it's a dual school year because it's 11, 12. So, and the same for years 9 and 10. You can join us, but we won't have you perhaps participating in that because you haven't done the first part of it, unless, of course, you've come from identical curriculum. So we talk to students, we tailor what's best for them, we make sure it suits them. What's beautiful about our school is that there's people like James, head of year 12, here year 11, that will openly talk to parents and students, which is what we're learning with this lovely webinar and Zoom and the culture that we're in, is you can talk face-to-face no matter where you are in the world and get to see someone and talk about your specific enrolment requests and what would suit you best. We'll also help you decide which of those articulations would suit you best. So when we're talking about HSC, or we're talking about VET, or we're talking about IB, will help you make the most informed decision. I am aware now, James, we are heading into, it's 5 minutes to 6, so thank you very much, James, for you.
Thank you for having me. I hope people found that useful, and maybe have a look at my channel later. Thank you.
They absolutely certainly will. And just for our audience watching, please do register for our next online webinar in our next episode, which is going to hopefully feature Dr. Brady Klein, who is our elementary digital learning specialist. And he's the person who's guided what we do in elementary in digital, but also what digital learning we do across the school. So please register again to come for another one of our curricular interviews that we have on our webinar series. Thank you, James. Thank you very much for our audience for joining us. Take care, everybody. Thank you very much.
Thank you, guys. Have a good evening.